Okay, we're going to solve a trig equation involving the sine function. The equation we have to solve is sine x equals 0.6, and we have to find all the values of x which are between 0 and 720 degrees. Incidentally, when you're solving this kind of problem, the interval tells you whether you're using degrees or radians. So in this problem, check to make sure your calculator is in degree mode. The first thing we have to do with this particular problem is find the principal value. Being a lazy mathematician, I'm going to abbreviate that to PV from this point forward. And we find it by doing the inverse sine function of 0.6. Let's work to one decimal place, and we find that it's equal to 36.9 degrees. We'll also need something called the secondary value. The secondary value is related to the principal value by subtracting it from 180 degrees. So if we subtract that, we will get 143.1 degrees. Now that we've found those, we can use them to calculate all the possible values of x which are true for this equation. We need the general solution formulas. That's what it's called. The general solution for sine, there are two equations we can use for this. So we can have x is 360n plus the principal value, or we can have 360n plus the secondary value. That's because the sine function repeats with a period of 360 degrees. So if we keep adding multiples of 360 to this, or we subtract them, and we do the same for this one, we can generate a list of solutions to the equation. So we do this by substituting values of n into each of those equations. So if we do the first one, we're going to get x equals, well, it will be 360 times 0 plus the principal value. So it will be 0 plus 36.9. So that's just going to give us 36.9. If we do the same with the secondary value, we're going to get 360 times 0 plus SV. So 0 plus 143.1. So the first two solutions we've obtained are just the principal and secondary values. If we keep going, we now do n equals 1. N is always an integer. So n equals 1 in here will give me 360 plus 36.9. So the next value that I'm going to get is 360 plus 36.9, and that's equal to 396.9. If I do the same value in this one, I'm going to get 360 plus 143.1, and that is 503.1 degrees. If I did n equals 2 into these two equations, I will get x is 720 plus 36.9, which is too big. It has to be smaller than that. Or I'll get 720 plus 143, which again is too big. So these are too big. N is 3, 4, 5, they'll all be too big as well. So the solutions to the original equation are 36.9, 143.1, 396.9 and 503.1. As a quick check, if you were doing this in the exam or a test, you could substitute them back into here and check that you got about 0.6. It won't be exact because we didn't write the exact answers down. In this second example, we've got another trig equation using the sine function, where we have to solve sine x equals minus root 3 over 2. This time the interval is given in terms of pi. That's telling you that we're using radian measure, so you should check your calculator is in radian mode before you continue. We proceed the same way as we did in the first example. We need the principal value. We find that from the inverse sine function. So it's minus root 3 over 2, and that's equal to minus pi over 3 radians. We need the secondary value, and we get it from the principal value by subtracting it from pi radians. Instead of 180 degrees, it's pi radians. Minus a minus means plus, so the secondary value is 4 pi over 3 radians. We'll need the general solution. There are two formulas for the sine function. In radians there are 2 pi n, and it's plus the principal value, but it's negative, so it's minus pi over 3. And we use the secondary value, so the other one will be 2 pi n plus 4 pi over 3. These two formulas will give us all of the solutions we need. We use them by substituting integer values of n into them. With n is 0, we're going to get x equals 0 minus pi over 3. So that's just the principal value again. With this one, we'll get 0 plus 4 pi over 3. So we're going to get the secondary value as a solution. That always happens with simple functions where we've just got an x here. If it's something more complicated, we don't always get the same two values again. We'll try n is 1. Put that into the first one. We get 2 pi minus pi over 3, which is equal to 5 pi over 3. So that's one solution. With the secondary value, we're going to get 2 pi plus 4 pi over 3. That's too big. It's bigger than the allowed interval. Okay, it's bigger than that value there. So we don't need that one. With n equals 2, we'll get 4 pi minus pi over 3. That's also greater than this value. Here we'll have 4 pi plus 4 pi over 3. Again, that's too big, so neither of those values is okay. So we'll try negative values. We'll go the other direction. With minus 1, in the first we'll get minus 2 pi minus pi over 3. That's smaller than this value, so we don't need that one. If we put n as minus 1 into the secondary value formula, we'll get minus 2 pi plus 4 pi over 3, and this is an allowable value. It's equal to minus 2 pi over 3. Okay, if we did n as minus 2, we'll get values which are also smaller than the lower end of the interval. So our complete set of solutions looks like this. So arranging them in order, we get minus 2 pi over 3, minus pi over 3, 4 pi over 3, and 5 pi over 3. We can check that these are the solutions again by substituting each of them back into the original, and we'll find that sine of each of these values is about minus root 3 over 2. It's about minus 0.866.